Alright, so in this video, I'm going to explain you the another game theory exercise, which is about imperfect information game. And let's first look at the exercise. Now we have an amount of money that accumulates, and in period t, its size is 2 times t. And that means, for example, in period 1, the total amount of this money is 2, right? It's 2 times t, so it is 2. And in period 2, then the amount is 4. And in each period, 2 people simultaneously decide whether to claim the money. Okay, so we have 2 players, and they will decide whether they will claim the money or not. If only one person does so, she gets all the money. And if both people do so, they split the money equally. And if neither person does so, both people have the opportunity to do so in the next period. That means in one period, both people simultaneously decide whether to claim the money or not to claim the money. And if only one person claims the money, that person will get all the money accumulated, right? And if both of them choose to claim, then they will split the money equally. And if neither person claims the money, then the games move on to the next period. And also, as it is indicated here, the total amount of the money also accumulates. It gets enlarged, right? And if neither person claims the money in period t, then each person obtains t. That means at the end of the game, which is in period t, if neither person claims the money, they will just split the money equally, and each of them will get t. Each person cares only about the amount of money she obtains. So first, we need to write the game in extensive form for case t equals to 2. Okay, so now let's just assume that there are 2 players, and we denote the players with 1 and 2. And let player 1 first make the choice. In period 1, player 1 will choose whether to claim the money or not, right? Claim or not claim. And then player 2 will decide whether to take the money or not to take the money simultaneously. And as player 2 does not know what is the choice of player 1, because they make the decision simultaneously, right? Player 2 doesn't know the choice of player 1, so it is basically with an imperfect information, right? So when player 2 makes the choice, it is with imperfect information. Not knowing the choice of player 1 is to claim or not claim. And then player 2 has 2 choices. She will either to claim or not to claim. And here, the same, either to claim or not claim. So basically, this is the game of period 1, t equals to 1. And then we see if both players claim the money, the game ends. If one of the players claim the money and the other not claim the money, the game also ends, right? Only in one case, when both players choose not to claim the money. So this is the case, right? Both of them choose not to claim the money. The game move on to the next period, right? And here, they will make the choice again. First, player 1 choose whether to claim the money or not to claim. And then player 2, also with an imperfect information, choose to claim or not claim the money. Okay, so this is the game of period 2, t equals to 2. And now we need to denote the payoff of each player, right? At each terminal node. And if we are here in period 2, we know the total amount of the money is 4, right? Because we are at period 2, and this is 2 times 2, this is 4. the total amount of money for them to divide is 4. And if both of them choose to claim, then each of them will get 2, right? Because they split the money equally. So this is 2, 2. And here, player 1 claims, player 2 not to claim, then player 1 gets 4, and player 2 get nothing. And player 1 not claim, but player 2 claims, then player 1 gets nothing, and player 2 gets all the money. And if neither of them choose to claim in period 2, then they also split the money equally. And here we also need to write a payoffs in period 1. In period 1, the total amount of money is 2, right? Is 2 times 1, so this is 2. If both of them choose to claim, then they will get 1 and 1. And player 1 claims, player 2 not to claim, player 1 get 2, player 2 get 0. Player 1 not claim, but player 2 claims, then player 1 get nothing and player 2 get 2. So this is the game tree. And now we need to find the subgame perfect Nash equilibrium. Let's just say SPNE for this game of imperfect information. So we also, this is a kind of game tree, it's kind of an extensive form game. And to find SPNE for an extensive form game, For an extensive form game, we need to use the backward deduction, right? So we need to first find in period 2, what is the kind of Nash equilibrium for period 2. And in period 2, this is also an imperfect information game. We need to find a perfect information set. Which is the perfect information set? Is it here? Is this a perfect information set? No, it is not. Because player 2, here, this is player 2 is not sure where she is, right? So the only perfect information set for period 2 is this. It's this one, right? And how do we find the Nash equilibrium in this information set? In the course, we know that an imperfect information game is basically a kind of strategic form game. Why? Because they make the choice simultaneously, and each of the player is not aware of the choice of the other player. So you can assume that you are playing a paper, scissors, stone game, even though player 1 first makes the choice, but he doesn't show his choice to player 2. And then in this case, player 2 also choose whether to play paper or stone, or scissors, okay? And then player 2 make the choice and they show their decision and they got the payoff. So this game is the same as they make the choice simultaneously and show the choice simultaneously, right? So we know that this kind of imperfect information game is just the same as a strategic form game. And that means we can solve this imperfect information game with the strategies we use to solve a strategic form game, and that is to draw that matrix, right? And we see in this information set, we have 2 players. The first is player 1. And player 1 has 2 strategies. The first is claim or not claim. The same, player 2 has 2 strategies. The first, claim. The second, not claim. And if both choose to claim, then they get 2-2. Player 1 choose to claim, but player 2 not claim, then 4-0. And this is 0-4, and this is also 2-2. So, what is the Nash equilibrium of this game? we see if player 1 chooses to claim, then player 2 chooses to claim. Player 1 not to claim, player 2 claim. And player 2 chooses to, or given player 2 chooses to claim, player 1 claim. And given player 2 chooses not to claim, player 1 will choose to claim. So the only Nash equilibria is this one, claim and claim. Claim, claim. Right? So it means that in period 2, the only Nash equilibria is this path, right? 2, 2, yes. And now we come to period 1. In period 1, the same. We have 2 players, player 1 and player 2. Both of them have 2 strategies, claim, not claim, claim, not claim. And if player 1 chooses to claim, player 2 chooses to claim, this is 1, 1. Player 1 chooses to claim, player 2 chooses not claim, this is 2, 0. And if player 1 chooses not claim, but player 2 chooses to claim, so this is 0, 2. And let's see, if player 1 chooses not claim, player 2 also not claim, so this is this path, right? What is their payoff? Their payoff is this, right? Because in period 2, they will only, this is the only Nash equilibrium, and that means the only possible outcome for period 2 is this. And so if they both play not to claim, they get 2, 2. All right, so what is the Nash equilibria of this game? Player 1 chooses to claim, player 2 chooses to claim. Player 1 not claim, both. Player 2 chooses to claim and player 1 claim. Player 2 not claim, player 2, sorry. Player 1 will choose to claim or not claim. So there are 2 Nash equilibria, right? These 2. The first is claim, claim. And the second is not claim, not claim. So what is the SPNE of this game? The first is player 1 chooses to claim in period 1 and claim in period 2, right? So this is CC. And player 2 chooses to claim in period 1, also claim in period 2. This is CC. And the other is player 1 choose not claim in period 1, but claim in period 2, NC. And player 2 choose not claim in period 1, but claim in period 2, is NC. So these are the subgame perfect Nash equilibria of this game. Okay. And now we look at the third question. Find the subgame perfect Nash equilibria for the general case when t is equal or larger to 2. So at this stage, we are still fixed in the case where t is only 2. We need to generalize our conclusion to t larger than 2. Okay? Now I'll just take them off. Okay, so let's assume the total number of games, of periods of this game is n. Okay, so this game is finite, but it is played for n times. And we still write the game tree of this game. In period 1, we still assume that player 1 makes the decision first. Player 1 decides whether to claim or not claim. And player 2, the same. As we did before, player 2 decides whether to claim and not claim simultaneously. Claim or not claim. Okay, so this is period 1. T equals to 1. And then the same for period 2, period 3, period 4, so I will not write them. And the same, only when both players choose not to claim, the game continues, right? And if any of them chose to claim, the game ends in this period. Okay, so let's assume n minus 2 times n minus 2 periods has passed during here, and I'm not going to write them. And let's just skip to the period equals to n minus 1. In this period, we get first player 1 choose to claim or not claim, and player 2 claim, not claim, claim, not claim. And finally, we got to the last period, which is equal to n. And in this period, player 1 chooses to claim, not claim. And player 2 claim, not claim, claim, not claim. Then we need to write the payoffs, right? So here we are in period n. This is t equals to n. And remember, the total sum of money for them to divide is what? It is 2 times n, right? Remember, this is the total sum of money. So in this period, we're gonna divide 2n. If both players choose to claim, then they get n and n. Player 1 claim, player 2 not, 2n, 0. Player 1 not claim, player 2 claims, so this is 0, 2n. And if both of them not claim, they equally divide the money, so this is n. And in period n minus 1, the total sum of money is 2 times n minus 1. Or we can just write them 2n minus 2, right? These are the same. And if both players choose to claim in period n minus 1, then each of them will get n minus 1, n minus 1, right? Player 1 claim, player 2 not claim, so player 1 get 2n minus 2, 0. Player 1 not claim, player 2 claims, so this is 0, 2n minus 2. Okay? And in period 1, they're gonna divide $2, right? Player 1 claim and player 2 claim, so each of them get 1, 1, 2, 0, 0, 2. Okay. So in the same way we solve the puzzles in the quiz in the second question, we use backward deduction, right? And here we start from the period n. And in this period, let's see. In this period, we have 2 players. Player 1, claim, not claim, claim, not claim. And what are their payoffs? If both of them claim, so this is n and n. And here, player 1 claim, player 2 not claim, 2 and 0, 0, 2 and also n. So what is the Nash equilibrium? It is here, 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 and here. And so the only Nash equilibrium is both of them claims. So this is the Nash equilibrium. Right? And we will move on to period t equals to n minus 1. And in this period, player 1 claim, not claim, claim, not claim. Both claim n minus 1, n minus 1. And player 1 claim 2n minus 2, 0, 0, 2 minus 2. And if neither of them claims, or both of them choose not to claim, they get what? They get n and n, right? N and n. Sorry. This is n. And what is the equilibrium? So we need to compare. Let's see. Given that player 1 choose claim, player 2 will decide whether to claim or not claim, right? So this is between n minus 1 and 0. And we know that n is larger than what? Is larger than t. Because we see here, in this quiz, we are assuming that players are playing in multiple periods, and the number of periods is larger than 2. So, and here we denote the number of periods with n. That means n is larger or equal than 2. Okay, so this is larger than 0, and this is larger. And here we also need to compare 2n minus 2 and n. Which one is larger? 2n minus 2 minus n equals to n minus 2, right? And we know n minus n is larger than 2, so this is larger than 0. So which is larger? This one is larger, right? And here, this is larger, and here the same. 2n minus 2 and n, 2n minus 2 is larger. So the only Nash equilibrium is 2. So in period n minus 1, the only possible scenario, or we say the only Nash equilibrium, is both players choose to claim the money. And my question here, will this game end with both of the players get A and N? Or, let me put it another way, can both players claim the money in period M and both players get N be a possible outcome for this game? No, it can't, right? Because we see here in period n minus 1, both of the players will claim the money. The game will end here. It will never come to here, right? Because both players choose not to claim the money is impossible. It's not an equilibrium. So we will never arrive at here. The game will always end with both players claiming the money here, right? So, okay, now let's move on to period 1. In period 1, player 1 claim, not claim, claim, not claim. And if both claim, they get 1-1. If player 1 chooses to claim, not claim, and this is 2-0, 0-2. And my question is very important here. If both players choose not to claim, what will they get? What will they get? If both of them choose not to claim, will they get AN No, they won't, because we know what? As I've explained, in period 2, most of the players will choose what? Will choose to claim the money. The game will definitely end in period 2, right? Let me say it again. In period 1, if both players choose not to claim the money, the game will never arrive at here, or any other place. It will only arrive at period 2, because in period 2, both of the players will choose to claim the money. And the game will definitely end in period 2. Okay? So, if the game will end in period 2, the game will end in period 2 if both players choose not to claim the money in period 1. What is their payoff of not claiming the money? It is 1 and 1, right? Because in period 2, we divide $2. And in period 2, both of them will claim the money. So we get what? We get 1, 1. And what is the payoff? What is the equilibrium? We see player 1 claim the money, okay, and here, and here. Sorry, did I wrote something wrong? Oh, sorry. They are in period 2. They are dividing $4, right? They are dividing $4, not $2. Remember, the total sum of money is 2 times t, and t now equals to 2, so this is 2 times 2. They are dividing $4, and that's why they are each of them are getting $2. Sorry. Okay, let's do it again. So 1 still better than 0, 2, 2, and 1 is better than 0, and here 2, 2. So in period 1, there are 2 Nash equilibria. The first is both claim the money, and the second is both not claiming the money. So the first is claim, claim, and the second is not claim, not claim. So what are the SPNE of this game? There are 2 types of SPNE. The first is that in period 1, both players claim the money, and in the subsequent all periods, both players claim the money, right? So this is for player 1, they claim the money in first period, and in the subsequent periods, they also claim the money until the end of the game. They also claim the money, and the same for player 2, right? This is the first, and the second is in period 1, both players choose not to claim the money, but in the subsequent periods, both players will always claim the money, right? So only in period 1 they are not claiming, and in the subsequent periods they always claim the money. Okay, so these are the second perfect Nash equilibria of this game. All right.